Who is our common ancestor? Have you ever stopped to think that, despite living on different continents, speaking different languages, and having totally different customs, we all carry the same person in our family tree? If we literally counted every second of human history, we'd end up with a number so huge it could even be scary. But before you get lost in that sea of billions, answer this. Who is the most recent person who was an ancestor of all of us? Today, we'll dive into one of the biggest mysteries of genetics in history, our common ancestor, the individual who, a few thousand years ago, was a great-grandfather to every living human right now. Ready? Then, hello? Hello, YouTube? We're bombarded with news reinforcing divisions of nationality, race, religion. Science says otherwise. Most of the genetic variations we use to differentiate peoples are superficial, recent adaptations. If we can pinpoint one single convergence point, everything gains a new meaning: universal belonging. The most recent common ancestor, or MRCA, is the most recent ancestor that every living human shares. Genealogy models simulate marriages, migrations, and birth rate rates over thousands of generations. When two lineage trees intersect, the node closes. A 2003 study estimated the MRCA lived roughly 2,000 to 4,000 years ago, between 150 BC and 258. If the MRCA lived around 500 AD, he'd have been born about 2,000 years ago long after Homo sapiens first appeared in Africa. How do scientists arrive at this date? First, mitochondrial DNA analysis. Mitochondria have their own genome, inherited exclusively from the mother. By comparing point mutations across thousands of people, researchers built a molecular clock showing when maternal lineage is split. Second, Y chromosome sequencing. The Y chromosome passes only from father to son. Accumulated mutations let us estimate the age of Y atom. Third, coalescence models simulate populations over time, including interfamily marriages, migrations, and wars. When all lineages merge, that convergence point is the MRCA fourth. Historical and archaeological data records of trade routes help us understand how connected the world already was. Where might the MRCA have lived? Several studies point to Taiwan or coastal Chinese islands, which were maritime trade hubs where many travelers met. Indonesia is another candidate strategically between the Indian and Pacific Oceans, encouraging many lineages to intersect. Kamchatka in Russia was a crossing point for nomads moving between Asia and the Americas. Japan's ports also received travelers from all over East Asia. All these places were busy ports or exchange centers. When thousands of genealogical lines cross at the same spot, the chance of finding the MRCA spikes dramatically. Why is incest fundamental in this story? Pure exponential genealogy without any intermarriage would give billions of ancestors, just 30 generations back, a number impossible to sustain. In reality, cousin, uncle, niece, and other close kin marriages were the norm, especially in small societies, tribes, or city-states. Famous examples include Charles Darwin marrying his cousin Emma Wedgwood, Albert Einstein and Malava Merrick being third cousins, and European royalty forging alliances that, in practice, were close kin. The result is that the real number of ancestors is dramatically lower than the pure exponential calculation, allowing us all to share the same Mr. CA who is mitochondrial. She is the woman whose mitochondria still circulate in every living human today. Her estimated date is 150 to 200,000 years ago in Africa. Other women also left descendants, but their lineages died out through childlessness or early death. Mitochondria replicate only via the ovum, so Eve's maternal line stays intact while others are lost. Evie shows that even before the recent MRCA, all of us already shared very ancient maternal ancestors. Y chromosomal Adam is the man whose Y chromosome still appears in all living men today. His estimated date is about 338K years ago, also in Africa. While mtDNA follows the maternal line, Y-DNA follows the paternal line only, which is why Adam and mitochondrial Eve have different ages. Not every modern human is a direct descendant of both. Some men still carry Y-DNA from other ancestors that never became universal. Why can we still trace this ancestor? Each generation accumulates tiny changes, single nucleotide polymorphisms that act as date stamps. Global genomic databases like 1000 Genomes, HotMap, and Nomad store millions of sequences, enabling planet-wide comparisons. Coalescence inference algorithms use probabilistic theory to estimate when different haplotypes last shared a common ancestor, even without written records. Molecular biology gives us a precise enough clock to point to the MRCA. So who exactly is this ancestor? Multiple candidates appear across different analyses, but consensus points to a man living roughly 2,000 to 4,000 years before Christ, likely a trader or travula, frequenting East Asian maritime routes. He probably had a profession such as trader, fisherman, or artisan, so highly mobile with many descendants spread across regions. He likely lived near a busy port Taiwan, Indonesia, or a coastal Chinese community and might have had multiple wives or partners. Common in maritime societies of the era, boosting the spread of his genes. In short, he wasn't the first human. He was the first whose offspring dispersed far enough that, millennia later, every living person still carries at least a fragment of his DNA. What are the social and philosophical impacts? First, human uniting knowing we're all cousins can reshape how we view conflicts and prejudice. Second, modern relationships. In dense cities like Sao Paulo or New York, the chance of sharing a fifth-generation relative is high. That's why when someone claims I'm descended from a certain king, you probably have some distant connection. Third, genetic responsibility. Sharing the same evolutionary story means we're also responsible for preserving genetic diversity, avoiding extreme inbreeding. Fourth, sense of belonging no matter where you come from. We all share the same root. If this dive into human genealogy made you see people around you differently, hit the like button. Comment below who you think could be your closest relative, maybe a king of England or a fisherman from Taiwan, and subscribe so you don't miss the next episodes where we explore how DNA can reveal who we are before we even born. If you want to go deeper, check the links in the description. There are scientific articles, a parental relationship calculator, and even a free mini guide to build your own family tree. Thanks for watching, and remember, the next time someone says, we have nothing in common, answer, actually, we share the same great-grandfather. See you next time, History Explorers.